Okay, good evening, good morning. This is Professor David J. De Los Reyes. Okay. My topic for this session will be a long video format discussion on college algebra, and this will now be lesson number 46. Okay, let's proceed. The topic for tonight will be college algebra, long video format discussion, and this is now lesson number 46. We are running smooth on our college algebra, okay? So we started from the fundamental operations and we are now on the solution of exponential and logarithmic equations. We are a little bit far already. Okay, let's proceed. The title of the topic for tonight will be exponential and logarithmic equations, meaning I will be presenting an example problems on how to solve for the unknowns involving exponential and logarithmic equations. Okay, let's try to bring out first the properties. And these properties, guys, for those who are watching short videos, this is the concepts they are using to solve problems under the short videos on YouTube. Okay, properties. There are only two properties, the exponential and the logarithmic thing. At least you know the relation of what you call this exponential and logarithmic. You know how to convert an exponential to a logarithmic and logarithmic to exponential. The properties are only two. For the exponential, a raised to x should be equal to a raised to y. Okay, the second one, the logarithm of x with the base of a and the logarithm of y with the base of a, they are equal. There are conditions to follow for the logarithm. X should be equal to y, and x should be greater than 0, and y should be greater than 0. Because if x is less than 0, that's impossible. It's undefined. If x is also 0, that's also impossible because there is no such thing as the logarithm of 0. Okay? Let's try to bring out the concept on how to solve an exponential equation and second, the logarithmic equation. If we are given an exponential equation, okay, there are procedures to follow on how to solve for the unknown, even for the logarithmic. Okay, they are the same. Okay, I will try to discuss how to solve problems if the given equation is an exponential equation. The number one rule is actually to isolate. Isolate meaning all constants should be on the right and the exponential equation or terms should be on the left. That's the meaning of isolate. Okay, you try to segregate. All constants to the right and all the exponential terms to the left. That's isolate. Number two, rewrite in logarithmic form. Oh, that is now the so-called conversion. If you are given an exponential equation, okay, to simplify it, okay, take the logarithm of both sides. Or meaning to say, you convert that exponential to logarithmic. That's the meaning of this. Rewrite in logarithmic. I will show you later on as we solve the problem. And lastly, solve for the unknowns, of course. Okay, meaning after taking the logarithm of both sides, you try to simplify, then solve for the unknown. For the logarithmic equation, it's the same. Isolate. If there are logarithmic terms, put it on the left, all the pure constants to the right. Okay, that's number one. It's the same. The next step will be rewrite in exponential form. If the given equation is logarithmic, the enemy of a logarithmic is actually the exponential. So take the rewrite the equation in the so-called exponential form. Raise both sides to the given equation to the so-called exponential form. Oh, that is the term to as antilog. Logarithmic, we are given a logarithmic equation. And the enemy of a logarithmic is anti-logarithmic. So take the logarithm of both sides to eliminate that logarithm thing, right? And after taking the logarithm, which is now in the so-called exponential form, solve for the unknown after the simplification. It's the same. Okay? Okay, let's try to bring out an example problem. This is an easy one. This has been coming out in the shorts videos in all my co-bloggers, what they call this, many things have come out, you know. So if you just know the concept they are using, there will be no problems. But tonight or this morning, I will be discussing the concept on how it should be performed. Uh, I will show you how those terms cancelled out, okay? Okay, example number 1. Solve the exponential equation for x. We are given an exponential equation. That is 3 raised to x plus 4 equal to 3 raised to 12. So we are using property number 1. Right? So we are given an exponential equation. So the rule on how to solve for the unknown will be the, what do you call this, number 1. You try to isolate the exponential term on the left and pure constant on the right. But if we try to inspect the given equation, the exponential terms is already on the left and the pure constant term is on the right. So we could say that the given equation, given exponential equation is already isolated. So we perform rule number 1. Okay. What's next? You convert this exponential to logarithmic. And how do you convert? How do you convert? If you are given an exponential equation, to convert it to logarithmic equation, take the logarithm of both sides, right? So take the logarithm of both sides. So the logarithm of 3 raised to x plus 4 equal to the logarithm of 3 raised to 12, right? And what's the rule under the logarithm? The logarithm of x raised to n, okay, can be written as n, the logarithm of x. Okay, so we will be using this one. So for the left hand side, the base is 3, the exponent is x plus 4. So if we try to take the logarithm, we could follow this one. We could bring down the exponent times the logarithm of the base. It's this. Okay, I want to show the cancellation. I will not just cancel out without showing it. Okay, and this should be equal to, this is also under this. So this will be the base, this is exponent. So if we try to take the logarithm, it will be the exponent times the logarithm of the base, right? And this is now where the magic that's going on short videos. They are canceling things, but I want to show you why we cancel. This is logarithm of 3, right? And this is logarithm of 3. So actually we could cancel this one. You can replace this by 1, this is by 1. That's the proper way to cancel. Okay? That's not magic. So you cannot just say, since e to the x is equal to e to the y, okay, since their bases are the same, their exponent should also be the same. No problem with that one. I like that one, but I want this one to be clear enough. That is, if I will take the logarithm of both sides, this is logarithm of 3, this is logarithm of 3. Right? So you can cancel out. Right? So what remains? X plus 1 times 1 equal to 12 times 1. So x plus 4 equal to 12. So x now will be 8. That is after the transposition. This is the way I would like to cancel out. Okay? I don't mind using property number 1. Okay? I want this to be clear. I will cancel out this one because they are the same. But if you follow property number 1, there's no problem. You equate since the base are the same, the exponent should also be the same. No problem with that one. Okay, next problem. Am I still on camera? Next problem. We are still given an exponential equation. So I will be presenting 2 exponential equations, then 1 logarithmic equations. The next exponential equation is 8 raised to x minus 2 equal to 512. The problem is asking for the value of x. So it seems we are still under exponential equation, right? So try to isolate. All the exponential terms should be on the left, all the constant terms on the right. I think it's done, right? So it's already isolated. Isolated. Done. Right? What's next? We got a little problem because the right hand side is just 512 and it seems it got no relation with that left hand side. So we will try to look for the proper relation. 512, okay, if you got your calculator, you try to divide this by 8. Okay, if we try to divide this by 8, the other multiplicand will be 64. And if you try to notice it, so we could take the relation of 8 to 512. So divide 512 by 8, it will be 64. And luckily, 64 is just 8 square times 8 again, so that will be 8 cubed. So meaning to say, 512 can be written as 8 raised to the third power. So after converting this 512 to the base of 8, you got the relation already, right? So it falls under property number 1. Okay? Others just equate x minus 2 equal to 3 because they say their bases are the same. But for me, I don't like that one. I will take the logarithm of both sides. I think that's the best way to present that it will cancel out, right? So if we try to take the logarithm of both sides, okay, we will still be using this one. The exponent, this is the base. So if we try to take the logarithm, it should be the exponent times the logarithm of the base equal to, the exponent is 3, this is 3, we bring it down, we're following this, times the logarithm of the base again. And again, this is the proper way to cancel out, right? But if you go directly to this, you equate the exponent, there's no problem. I got no problem with that one. But it's hard to understand that one. But for me, if I will take the logarithm of sides, I can say that this logarithm of 8 cancel with this, right? So this will now be 1, this is 1. So x minus 2 times 1 will be x minus 2, and 3 times 1 will be 3. Okay, so x now will be equal to 5. I want this one, right? I don't want that. Okay? That's the proper way to show that it cancels, right? That's it for the exponential. Okay, the last example for this morning. Solve the logarithmic equation for x, meaning we are given a logarithmic equation. Logarithmic, it got a logarithm thing. The base might not be 10, might not be e. For the given problem, the base is 2. Okay? So this is a pure mathematical problem. It doesn't have any relation with the so-called electrical logarithm, that is the natural law. The base is 2, because actually we can solve problem with any base. But the common logarithm is actually the base e and the base 10. Okay? For mathematical, what you call this, problems that goes on YouTube, you could take any base. Okay? The given logarithmic equation is the logarithm of x with the base of 2 plus the logarithm of the quantity 3x plus 10 with the base of 2. Okay? Same base. Minus 3. And this should be equal to 0. And the problem is asking what will be the value of x. So we are given a logarithmic equation, so we must have to follow rule number 2. Isolate, rewrite, okay, rewrite to exponential, then solve for x. Let's try to isolate. But before we isolate, okay, we could isolate now. Okay, this is minus 3 pure constant, right? So if I will transpose this to the right, this should now be equal to 3, right? So we isolate already. Logarithmic terms, the pure constant is on the right, it is 3, right? Then try to simplify the left hand side. The logarithm of ism. The logarithm of the product xy, okay, can be written as the logarithm of the first one plus the logarithm of the second one. So if we are given an addition logarithm, we can simplify this one by simply putting one common logarithm sign, but we must have to take the product, right? So the left hand side, under one logarithm sign, can be written as, because this is addition, right? It will be the product of the first one times the second one under one common logarithm sign. Okay, so we are now given a logarithmic equation, okay, simplified, in which this is simplified already, and the right hand side is a pure constant. Okay, so we could say they are already isolated, right? Isolated. What's next? To solve for x, eliminate the guard logarithm. And the enemy of a logarithm is anti-logarithm, right? So we must have to convert this logarithm to exponential, right? And the enemy of a logarithm is anti-logarithm, and the proper way on how to write antilog is you get the base, you raise that to the given left-hand side. Meaning we are taking the antilog of the left-hand side. Where did I get the 2? I get it from the base, right? Because to eliminate this logarithm, I must have to take this 2 here, raise to this. That is termed to as antilog. And for the right hand side, the antilog of 3, this is 2, right? So I will follow this is 2, and I will raise that to the given right hand side. This is termed to as antilog. Anti-logarithm. Right? The enemy of a logarithm is anti-logarithm. So it will vanish. The antilog of the logarithm of the given function is just the given function. The given function, I expedite a little bit. I multiplied already. So this is 3x squared plus nx equal to 2 cubed. So if I will try to take the antilog of the logarithm of this will just be simply the given exponent. Right? Right? We are taking the antilog. The antilog of a logarithm is just a given function equal to 2 to the third power is actually 8. I place it on the left already. This is minus 8. And this should be equal to 0. So actually we are now given a quadratic equation. And to solve a quadratic equation, okay, there are lots of solutions. By factoring, by inspection, by quadratic formula, by completing squares, or by taking the square root of both sides. But the fastest solution for this one will be the solution by factoring. So 3x squared plus 10x minus 8 equal to 0. Possible factors of 3x squared will be 3x and x. And the possible factors of minus 8 will be positive 4 and a negative 2. If we try to check the middle term will be minus 2x plus 12x, it is 10x. So these are the possible factors. Equating each factor 0, x1 now will be 2/3, automatic, we lack space. x2 will be equal to negative 4. But for the value negative 4, we disregard this one. And the proper answer for the given problem will be x1 or x will be equal to 2/3. If we place 2/3 in the given original equation, what comes out is a true thing. But if we place x to be equal to negative 4, if you try to take the logarithm of negative 4 with the base of 2, that's impossible. So this is disregarded. So the proper answer for this given problem is x1 will be equal to 2/3. Answer. It's very nice. So at least you now know how to solve problems under the short videos that's coming out. Okay, this is the concept. So for those of you who are taking up college algebra, this is for you guys. This is the proper concept on how to solve in an exponential and logarithmic equation. So if you want to subscribe to my channel is at youtube.com/@profdvgdelos. If you want to share it, please click share. Okay, try to watch my videos. You will learn some concepts on it. So when you watch what I call the short videos under these topics, you will not be having difficulty. Okay, good morning from Los Angeles, Professor David J. De Los Reyes.